Steel. Oh, hi guys and welcome to a new episode on the channel. Wait a second, let me eat all of this first. So good. So today we will be talking about Cosmos by Carl Sagan. Chapter 1, the shores of the cosmic ocean. Hey, could you order some more? Thank you. Pretty good. And let's start talking about the french fries, or this orange juice for that matter, even though this may be related, and go on to the shores of the cosmic ocean. Now, what does an ocean has to do anything with the cosmos? Not the television show or the book. The actual cosmos, the universe. And no, not the computer from Jordan the Secret Key, the George book, like those books over there. Yeah, the ones I'm on my fingers on top of right now. Yeah, no, not that cosmos at all. We're actually going to talk about the real cosmos, the one that the computer cosmos is mapping. If you know what I mean, you should have read those books. But anyway, back to the point. Let's just think of the cosmos as a cosmic ocean of water. Every molecule is like an ocean, and well, for this purposes and for me drinking this, I will think of it as orange juice, a sea of orange juice. So now, let's say that it's like the ocean, and when it is like the ocean of the shore, it seems that we know most of it, what we do. No. Now we know a lot about the ocean, but all of that, a lot things that we know about the ocean, it's just a few percentages of the actual whole percent of the explored ocean. We've only explored a percentage, a very small percentage, less than 5%, I guess about 3% of the ocean. And now we need to find, or at least we want to find out about other things. So we can either mine gold there, which is gonna be pretty awesome if we will be able to get gold for that matter. And also, we can also have some, well, sort of other advantages to it. We can use the oceans, thermal hot thermals, like those little pipe thingies that put the heat out, into our energy sources. But for the cosmos, we literally know almost nothing about it. Okay, not nothing, but a lot. Still a lot, but we don't know a lot. More than we know about the cosmos. We actually know it. See where I'm going with this? And that's my comparison. And now let's go back to orange juice. Now let's just say that I just drank that this bottle, all the percentage of it, all the parts, all the orange juice I drank is how much of the ocean that they will found. And eventually they will really want to have this all the way back to down, but I will not drink it in one go because I'll get brain freeze. And no one loves brain freeze. Okay, except brain freeze people, but that don't count. And what is the galaxy made of? Why am I coming to this question anyway? Because it's the cosmos. Well, it is composed of gas. Yes, dust. That is similar to dirt. Stars. Oh, and if you even don't believe it, that's actually true. Dark matter. And it is said that there's a black hole in the center of our Milky Way. So maybe black holes in some galaxies. And eventually galaxies may be individual universes to us, but that's for a different topic. But since it will be awkward to measure long distances with our regular miles or kilometers or meters, okay, meters would be very, very stubborn to use while measuring stuff in space, especially distance between planets and stars, or planets between planets. We use this called light years. It's about how light years measure how long a straight line of light can travel through 1 year. And that is pretty much a lot. I just can't believe that this is actually happening, but it turns out that light years are very useful, except, well, we've proved that light isn't really useful with time, and Einstein actually proved that, but that's for a different episode. Just go watch other episodes about Einstein's general relativity and what it does with time. But let's ignore time for a moment, and let's just explore the cosmos. I mean, there are many galaxies out there, like, okay, scientists are the worst at naming things. M31. And I thought that the Alpha Centauri could get worse. And it has 2 small satellites. No, not the artificial satellites, the natural satellites, like the moon, in there. And these are pretty good. And I have to admit that this cosmos thing is better than I ever thought. And this guy named Eratosthenes, yeah, I see that's how you pronounce it, Eratosthenes, a Greek, a guy a mathematician who lives in Alexandria, Egypt. I guess you can guess where Alexandria was named after. Alexander the Great. Snack break. And as much as I really like this about mathematics, well, not as much as angles and stuff, but still, I like mathematics. Eratosthenes made this discovery. He accurately measured a circumference of the Earth, that is the perimeter of the circle. Okay, go math talk here. Accurately, up to 99.99. Okay, he had an error of less than 1%. And he was just an ancient Greek, and that was amazing for 2,200 years. And if you look at our current date, 2022, that is a very long time, even in the BC years. Stressing. How did he do it? Well, firstly, he only had 2 things. 2 sticks, for the matter. He placed them in the ground, in different places, and started proving if the Earth was round or not. If the Earth was flat, then it would just be like the shadows would be the same. But if the Earth was round, they would not be the same, the length that is, and the shadows aren't the same. So, he said, the Earth is round! And no one actually believed him at first, but well, then they did. And yeah, I was wondering, how did he measure the circumference? Well, technically, he found out the distance between Alexandria and Siena, which was approximately 800 kilometers. And then he multiplied by 50, which is 47 kilometers. And that is very approximate to the whole circumference of the Earth. And that turns out is to be the right answer. And he only uses eyes, feet, and brains. And how did he do it? Well, the surface of the Earth is curved, and not only that, the greater the curvature, the greater the difference in the shadow lengths. And he also used a mathematical term to actually do it. By using like 2 parallel lines intersected by 1 line and measuring 2 angles from it. Okay, a little math here. Okay, let's go here. Angle A and angle B were both 7 degrees. And since they were exactly the same degrees and they were technically in the same places, they were congruent to each other. And that's how Eratosthenes made his great discovery. And because of that, a lot of other things happened. And even the first library was invented after that. And more ships were able to go around the world safely. Luckily, too. And right now, I think we're actually done with this episode, too. We've been talking about 10 minutes about this, and about the equivalent of half of a Cosmos episode. So, I hope you guys enjoyed this episode. If you did enjoy this episode, please like, share, and subscribe to this channel if you haven't already. And I'll see you in the next episode. Shout out.